have to test it to at least 50 kilopascal. So again, it works for Europe because they use this coding system, but outside of Europe, it has no value.
Then why don't you keep those table 3 and table 4? Just say you report it.
Yeah, that's what I'm suggesting. We can get rid of the table 3 and table 4 and just say declare as far as the requirements.
That makes sense. So other countries, if they don't have a requirement, they can, if they don't have any, what's the use for them to use those big codes?
It just tells them how to use a code.
And we're not going to, we don't have access to those things, we don't.
Well, they mean nothing to
Nothing.
anybody outside of SAM.
So table 3 and 4, we can just remove it, still they do the test and report the values.
Yeah.
I will take this. So, Lavan, in this, with the case of tensile and compressive strength, I don't have, I have to change some wording that which will do it. Yeah, because
Yeah.
I still mention CSY and all these things. On the creep also, at least 120 days testing, we have to do some wording change there too.
Yeah, so the first paragraph, I think we could leave in as is.
Which sentence is
This is in 436. Yeah, so in that, the first paragraph there, we've changed it to the ISO standard, which is 20392.
Okay. Compressive strength total thickness shall be determined after at least 122 days of testing at declared compressive stress given in steps of 1 kilopascal. Okay. At a declared compressive stress, we don't have a declared compressive stress if we don't have a this code.
No, we require that they declare.
They declare.
So it becomes a declared
Given
compressive
in
stress.
steps of at least 1 kilopascal, the results shall be extrapolated 30 times according to 10 years level in accordance with ISO.
ISO 20392.
ISO 20392. Compressive creep process declared in levels of total thickness. Do you have to keep this sentence?
The last one?
Last one you can say no, but that is it. You don't have to say the requirement here, isn't it?
No, we talked about the having this a declare.
Okay. So compressive stress shall be declared. I can take this whole thing off.
The second last sentence, I don't think we have to take off. The last sentence we do.
If shall be declared in levels I2 and
Because what they're saying is in ISO 20392 for compressive creep, that document requires that you do this.
So I can take the note all off.
Note 1 can come off. Note 2, you can, it shouldn't be a note. So that get rid of. Now note 2, I would take out note 2 testing times and just have it simply say, according to ISO 20392, the procedure at 10, 25, and 50 years respectively require the following testing times, because that is a requirement.
Yeah.
It's not a note.
Yeah, we discussed it yesterday. Now this looks clean.
Yeah.
to write 122 in English, in what? We can
It's
make
probably proper, but we don't normally do it.
yeah. I look at some shades to Arabic.
Yes.
Put it in bracket 122 days.
Normally for number, just if it's less than 10, we just write it in English. If it is superior, we just write it.
Okay, we'll get the ISO guideline for that. Okay, so I go back to the table. Near the table. So compressive strength. See table. So we can take these tables off. So it will be declare or report.
Declare is a term we typically use.
Okay. Tensile strength perpendicular face is also declare. Compressive creep is also
Yeah.
declare. Right. Shear strength, and let's go to the shear strength. Shear strength shall be determined according to ISO these. Declare.
Declare.
So if I understand this right, for shear strength, you're basically attaching to the two sides of the panel
Yeah.
and creating a shear.
Yeah.
So it reflects on,
If you're gluing this on panel, that what kind of load it can take.
either, you would think that you would need some sort of minimum there.
But see, if you are not gluing, if you are putting between two insulations, you really, and you are not, nobody is suggesting to use the vacuum insulation panel as a load bearing component. And if there is a huge racking force or something is there, we're not going to use vacuum insulation panel.
But if you're, I view this as something you wanna do to know that whatever you've done to your panel, it sticks together. So if you're, and I'm exaggerating, but if your result of this is 1 Pascal, to me, you can't even handle it. It's not a big deal, but to me, to have shear strength and simply declare, what does it mean, right?
Okay, what it means, if you have got 10 products, right? One is say, hypothetically speaking, 1 Pascal, that's probably not realistic. Another has got 500 Pascal, right? If I'm gluing it, my choice will be, though I don't expect any high stress there, I'll go for the product which has got higher strength, isn't it? But if I'm just using it, that is,
See, you're jumping to applications.
you be jumping to applications
The
here.
manufacturer that produces this panel does not know where it's gonna be installed.
Yes, but they are giving, the declared values are the things to give guidance to the end
But-
users.
Okay, so the architect takes a look and he says, well, I got 50 kilopascals on this shear strength, what does that mean to him? If the product's been engineered to stay together at 10 kilopascals, the user of the panel has no idea about that.
Okay, if say I've got a shear stress value, say 50 Pascal, okay, and I'm an architect, I'm using this one, and I say, well, I'm gluing it, and I anticipate there will be some forces, okay, it has to transfer, some forces will come to that, though it's not designed, but there's a minimum force will come. So
So now you're jumping to become a structural panel.
Mhm.
If you're gonna put loads in that panel, then that's some sort of structure to it. So, and that's my basic question, is shear strength only for quality control of the manufacturer? That they need, I mean, I relate this to the construction site with tapes. We have construction tapes that you pull off by blowing on construction tapes that, you know, you probably have 50 kilopascals and you can't get them off. And so we have in the industry, we have established, we want a minimum value so that we know it will stick over time. So the question to me starts off is what is this for? And is it for quality control for the manufacturer, or is it for it to become a structural component, even if it's a minor structural component in a building?
That's a good question. I'll try to be safe. I'll say it's for the manufacturers for quality control.
Then my next question is, why do we have it?
Why we
That
have
is the only purpose, because if he's the manufacturer, he knows what his panel has to do to stick together and not rupture and so on and so forth. Having that value given to me as a user of his panel means nothing. Like, I'm not gonna do a shear strength test to see if he's producing a quality panel, unless these panels are rupturing all over the place.
But that is same is true for the compressive strip. Same is true for the all declared values are same, isn't it?
Well, compressive creep, yeah.
Same for tensile strength.
Tensile, I would disagree with, and compressive, I would disagree with,
Why?
because you are, whether you like it or not, you're gonna have loads put on the panel.
But if you can accept the fact that some tensile and compressive load will come, so what stops you to think that shear load will also come? Because you are putting between two materials.
So then we're jumping to application, nothing wrong with that.
No, not
but,
wrong with that.
And I'm gonna go back to compressive, strength, can I walk in these panels?
If you walk on a panel, will depend on what you are wearing. If you are not wearing a sharp one, most likely you will be fine. Okay, but there can, depending on if there is a dart or something under your shoes, walking in this panel is not recommended.
But that's not compressive strength, that's puncture resistance.
That's the puncture resistance.
See,
Okay.
and here's where it comes. We have, in 163, we have ISO 9972, I believe the number, and it's a guideline to develop specifications for thermal insulation. So one of the things that they say you should do is determine these things for it. So if you're going to have insulation under a road, heavy traffic, here's what you have, here's a test method, here's what you have to do. If you're gonna have it on a roof, that there's gonna be temporary mechanical repair type of traffic, foot traffic, here's a different one. And if it's designed to never have a human step on it, here's another one. So I'm wondering whether we can apply some of that. Like, if you're gonna put thermal insulation in a wall, you're not gonna walk on it, right? And if you happen to have it laying on the ground, and
But people are putting it under the floor.
then that's a different category.
That's the category.
Let me just pull up that standard. So I don't think we have to nail it down today, but.
Just leave it as a report, but this is something, this standard is far away from finalizing, but we have to start working on it.
But I would like to bring that up, because I think in some cases we should, state whether this, like, what is the use of it? Is it only to be in a wall, for example, we don't expect to have anything on? Do we really care? Do we want it wide open? And maybe the answer is yes, maybe it's declare and we don't care and all the rest of the stuff, but I think it's worth a look at anyway.
For the time being, I think if we kept compressive, tensile and compressive creep, all of them declare, the shear strength declaring will not make any.
I want to talk about the size of specimen. Yeah. For the other test method, the size is very flexible. But for this shear strength, the size should be and 100. It is difficult to make the, yeah, it is for the product size exceeds this size. To test the shear stress, the manufacturer should make this size of the specimen. So my question is that, Laban, is it possible for us to test with other size plumb dam in ISO 16537? If ISO 16537 requires this size, so we should oblige. But if it is flexible, it is more advantageous to change from this size.
I don't have the copy of that standard, so I can't tell you on that one.
Yeah, and I don't have a copy on this computer, but I'm just checking the website.
Thank you.
Laman, as a part of this standard development, if I request ISO to give me the copy of those standards, they will give it to me.
Yeah, what you do is you approach SCC, and I can show you maybe after the meeting, there's a particular site that you go to, you make the request, and you get a copy.
I think I should, after finalizing this, the initial draft, I should ask for the copy for all of them.
Yes. What was that standard number again, 16537?
Yeah.
This is 567.
This is how the specimens look like. It's taken from a foam standard. There are probably two ways done, one specimen and two specimens. Basically, probably they kept the size same, they can use the same equipment. There is no reason why you cannot make another equipment and do a different size. But for the lab, if they're only doing for the foam for certain size, making another test setup, and vacuum insulation are produced in various sizes. Okay, so if you keep the flexibility, everyone will test in various ways. So if the foam has got already a size, probably they decided, let's do it in this size. We are not going to do for all sizes anyway. While you look for it, can I come from washroom for a second? So we are done with the table then.
I have one comment.
Go ahead.
Table 6 and thermal conductivity of punctured VAP is missing.
That's missing. Yep.
4.3.10. No requirement.
But at least we should report the value, isn't it? Even if it is not requirement, the punctured VIP, if we measured it, why don't you report it? That's a
But
good
if we have a requirement, it should be put in this table.
Well, then the problem comes. I think we cannot ask for a requirement in this case because there are so many types of composite core materials will come. Glass fiber will have one value, fume silica have another value. I think just reporting should be fine enough. Declare what is the declare. Declare because glass fiber will have one value, fume silica another value, So glass fiber will be basically, glass wool kind of thermal values. And again, it will depend also on the what kind of thermal bridge you have. So I don't see any benefit you will get it by putting, but the reporting the value will be definitely useful to know that if it what kind of R value you are expecting.
But should never be lower than the value of glass fiber.
It should not be lower than the glass
So
fiber.
that
No,
could
it
be-
can be lower than the glass fiber because now we have got a
Edge effects.
edge effects there. Just reporting the value will be good enough because if you are mentioning it, we should have included the 4.3.10, isn't it? So that's a good term. I did notice it. 4.3.10 punctured VIP.
I have other proposal. We correct the requirement in table 6. So from 4.3.2 to 4.3.10 is only test method. I think so. This part to move to 5 is better, I think.
You have to repeat it again. 4 point
4.3.10. This information is only test method. Like it.
4.3.2 dimensional stability, right?
Yeah, yeah.
There is a test method and there is a requirement.
So that requirement is in the
Table.
table 6.
Yeah. We will put that requirement in the table. Dimensional stability.
In the test method, in the test method, and nothing to write
About the requirement.
yeah, only requirement.
It needs to be requirement.
And
4 is requirements.
first part of is only test method.
The standard's kind of weird in that.
Where, yeah. So what, I understand, so I'll take a note that it should be test method, then the requirements, okay? They started with the requirements.
Well, and the other thing I think that you're bringing up is when we go to the current 5 test methods, it only talks about thermal resistance and thermal conductivity. So in ISO standards, I've seen one where they talk about general, and then they talk about the test methods, and then they have a table for requirements. We should either, the current 5 to me doesn't mean anything because it's the only test method and it doesn't talk about any of the other things, so.
Lavan, can you tell me what is the most common format? I'll write it in a document, so I'll try to rephrase it from things, okay? So let's go through all these things. First we will have scope.
Okay, that actually is provided to you in the rights document.
Okay,
Let me pull it up.
okay. Give me that copy, so I'll try to put it in the right way. I understand. It's not a technical thing, but it's organization. Okay. Let me get that document.
So if anybody's looking for this, this is on the ISO website, and it's under,
It's a PDF?
I think so. model standard. There actually is a RICE standard, but this is a model standard.
I go to committee home, no,
I just typed in RICE.
RICE or RIAC.
And this is, obviously it's for RICE, but it's designed to give you guidance as how you set them up.
Okay, did you went to the website?
Yeah.
For the ISO website,
Yes,
okay, and what is the spelling of RICE?
RICE.
RIC, I didn't get anything. Let me go to committee home.
Yeah, and the one I brought up is an amendment, so that doesn't help, so. It's in the, it's in standards development and like assistance.
ISO standard development. Okay, then you go to assistance. Standard support for public policies, standards and practice, documenting and partner organization, governance of ISO. Okay,
Now you're into you passed your scope, now you're into, so you have to have a scope and you have to have reference documents. And if you
Different
have no
documents.
terms and definitions, you state that.
okay.
Okay, now you're into requirements, you just passed.
Now that's the requirement. 3.2.
Actually, you know what, if you go to the table of contents, that will tell you, I think, what you're looking for.
And is it something which is, everybody follows it or there is some variations?
It's a starting point.
Introduction,
Yeah, so you have to
Scope.
have a scope, normative, and normative references, you can't get away from it. Then you have your terms and definitions, and you got that done, now you're into specifications. And we, had general requirements, we call them requirements, and we had, specific requirements or application requirements, and we blended them together. So that's what we go first, what are the requirements? Then we have the sampling, which we have a paragraph. Now you're into the test methods.
so this specification is basically the requirement, right?
Yeah,
And test report is basically, this is the test methods and this is the requirement. So that comes test report in the form of a table.
yeah. And actually, the ULC standards, we follow this.
Sign this, huh?
Yeah. And it's nothing's cast in stone, but to just give you guidance. So for this particular document, and for 163 SC 3, your 4, which is all your requirements, basically. For example, you say in 4.2.3, length and width shall be determined in accordance with ISO 29565 and with the seam, so that's an appropriate part in the requirements. And you reference a test method. Then you should be able to go to test methods and you do sampling, conditioning. We're not really doing any specimen preparation here, so that we need. And then you get into any details
Okay.
on the testing itself.
So I'll restructure it. Only thing I need to, Lavan, I may not have too many ISO standard in my
Yeah.
database, but I have a lot of ULC standard. So I can take one of those. There are various